Next theorem we'll study about the superposition theorem. Okay. In the superposition theorem will apply only when we are having more than one source available. Either it can be a voltage source or it can be a current source. Okay. Like for example, if this is the circuit and in this circuit there is only a single source, so we can't apply a superposition theorem in this particular question. We should have more than one source available. Okay. So what would be the step number one for the superposition theorem? We have to keep first source, okay, and we need to kill other sources, all other sources. Killing means that I told you that if there is a voltage source, okay, if there is a voltage source, then that voltage source must be in the Thevenin theorem. Remember, we calculated in the RTH voltage source must be short circuit or open circuit, short circuit, right? And current source must be open circuit or short circuit, open circuit, correct? Like for example, I'm drawing a simple circuit diagram. In this I'm taking only two sources available at this time, and we need to calculate current in suppose 6 ohm by using superposition theorem. Okay, so what we need to do, step number 1, we have to keep first source, okay, and kill other. So keep first source means which one is the first source? 10 volt is the first source and 15 ampere is the second source. Okay, so we'll keep first source, that is 10 volt, 4 ohm, 6 ohm, and current source must be open, right? Rest of the diagram will be same. Suppose current I is flowing here from up to down. So in this case also current will flow from up to down, but this time we'll mark it as I dash. Okay, because they are asking the current in 6 ohm. So we need to focus the current in 6 ohm only. We need to calculate I dash only. Got it? Now for the calculation of I dash, that depends on you. If you want to use mesh analysis, you can use mesh analysis. If you want to use nodal analysis, you can use nodal analysis. That totally depends on you. Okay? But I will suggest if you are doing superposition theorem, then nodal would be perfect for you. Why? There is a reason, because in this we need to calculate the current in the branch, and in the nodal method also we need to calculate current in the branch, right? Remember the mesh, we were calculating current in the loop, so we don't want current in the loop, we want current in the branch. But in this case, can you tell me, is this a node? Yes or no? This one. Is this? Is there any current flowing across 8 ohm? Yes or no? It is an open, sorry, it is an open circuit. So is there any current flowing across 8 ohm? No. So current across 8 ohm would be 0. So that means this is not a node, right? Because if no current is flowing, means no existence of wire, right? So in this we'll simply apply the mesh analysis, minus 4 I dash minus 6 I dash plus 10 is equal to 0. So now tell me I dash would be equal to how much? 1. Okay, understood? Now move towards the step number 2. That in the step number 2 have to keep second source and kill first source, means all other source, right? So in this case second source is what? 15 ampere. Voltage is what? 10 volt. So we need to kill first source, that is voltage source, that is short circuit, correct? Again the rest of the diagram would be same. Now we have to keep the second source, that is the current. Okay, this is 4 6 8 4 6 ampere. Got it? Now again in this we need to mark I double dash. Okay, first step, keep first source, mark I dash. Second step, keep second source, mark I double dash. If there will be third step, third source is present, then in that case you need to mark I triple dash. Got it? Now in this case we need to focus that how can we get the value for I double dash, right? Again, as you can see, this is a node because in this both in every branch current is flowing, right? So this is node VA, this one is grounded, correct? This one we can consider as I1, consider as I2, this one consider as I double. If I'll apply nodal analysis, then what would be the equation of current? Tell me. I1 would be how much? So minus VA by 4 because current is moving from 0 to I double dash would be, it is moving from VA to 0. So that would be VA minus 0 divided by 6. And I2 is how? Tell me about I2. Because I2 direction and 15 ampere direction is just opposite. So from this we can get the value for VA. Then substituting the value of VA in this equation, then we'll get I double. Right? We need to solve only one equation. If we'll do it by mesh analysis, we need to solve two equations. Again, that would be complicated. So now we got the value for I double dash, right? Now in the next step, what we need to do, I would be equal to I dash plus I double dash, right? I would be equal to I dash plus I double dash. Why I am adding? Because as you can see, I direction is matching with I dash direction and I double dash. So if the direction are same, then the current would add with each other. Now suppose if I take the opposite direction of I double dash like this. Okay, I'm not taking, but I'm telling you, if you take, don't take it. I will suggest you take the same direction to the main diagram. But if suppose if in any case you have taken I double dash direction in the opposite direction, then what you will do in the end, I would be equal to I dash minus double dash. So whichever direction you are taking opposite to the main diagram will always compare with the main diagram. That would be negative. If they have given in that direction, that is well and good. If they have not given the direction, then we can take it according to our convenience.